The formation of the covalent bonds. So the covalent bond is nothing but the sharing of electrons between the atoms, especially the non-metals will takes place in this. The sharing of the one pair of electrons, if it is a sharing of only one pair of electron, that we call it as a single bond. Suppose if it's sharing the two pair of electrons with one atom, it forms the double bond. If it shares the three electrons with this one atom, that it forms the triple bonds. So the formation of the single covalent bond in the hydrogen molecule. So the hydrogen is the first element in the periodic table. So it has atomic number 1 and also the electronic arrangement is also the 1. It has a valence electron 1. So hydrogen wants to attain the stable noble gas configuration. So it needs one more electron to complete the outermost shell. So it is a non-metal, so it always undergoes the sharing of the electrons. It, so what it will do, so this is one hydrogen atom, this is one hydrogen atom. So each hydrogen atom is having the one electron in the outermost shell. So when they are trying to make the bond, so this hydrogen atom will give one electron, this hydrogen atom will give one electron, so both will make a bond. So hydrogen, single bond hydrogen. So this we call it as a single covalent bond because it shares one electron to the other atom. So it's a normally we call it as a H2 molecule. Hydrogen always occurs in the state of the H2. It's a diatomic molecule. Is the formation of the double covalent bond in the oxygen molecule. So the oxygen is present in the group 16. So it has a atomic number 8. So the electron is also the 8. So the first electron, the two electrons occupy the first shell. The 6 electrons will occupy in the second shell. So now it needs two more electrons to complete the outermost shell. So what it will do is, this is the oxygen atom. So it's having a 6 electrons in the outermost shell. So this is the another oxygen atom. It is also having the 6 electrons in the outermost shell. So this oxygen also need 2 electrons. This oxygen also need 2 electrons. So this 2 electrons it has to share and these 2 electrons it has to share. So finally it will share the 4 electrons total. So it makes a double bond in between the two oxygen atoms and it forms the O2. Again, oxygen is also the diatomic molecule. Next one is the formation of the triple covalent bond in nitrogen molecule. So the nitrogen is present in the group 15. Its atomic number is 7. So the number of electrons is 7. So the electronic configuration of the nitrogen is 2, 5. So out of the 7 electrons, the 2 electrons will occupy in the first shell. The remaining 5 electrons will occupy in the second shell. So now the nitrogen needs 3 more electrons to complete the shell. So if the nitrogen needs 3 more electrons, it has to share the 3 more electrons from it. So 1, 2, 3, 4, 5. So it has a 5 electrons over here. So out of the 5, the 3 electrons it has to share with the other atom. The other atom is also the nitrogen. So this nitrogen also needs 3 more electrons to complete the outermost shell. So it also has to share the 3 electrons with the other atom. So finally, so this nitrogen is sharing the 3 electrons. This nitrogen is sharing the 3 electrons. So it makes the triple bond N, triple bond N. It's a N2. So this is the triple covalent bond. So the nitrogen also highly reactive as a atom, but the nitrogen N2 is a inert. It is actually a inert. It does not react at the room temperature because it's having a triple bond in its structure. So why it is inert? Because we have to supply the lot amount of the energy to break this three bonds. That's why it is inert at room temperature. So at high temperature, it starts reacting it with the other atoms. Okay, so now this is the hydrogen molecule, and so the hydrogen is having a one electron in the outermost shell here. So this is another hydrogen atom. This also has a one electron in the outermost shell. So both wants to attain the stable configuration. So both shares one electron each. So this is the single covalent bond. So between the hydrogen atom, H single bond H. Next one is the F2 molecule. So the F2 molecule is each fluorine is having atomic number 9. So the number of electrons 9. So out of 9 electrons, the 2 electrons will be present in the first shell. The 7 electrons will be present in the outermost shell. So it needs one more electron to complete the shell. So this fluorine atom also needs one more electron to complete the shell. So both fluorine atoms share the one electron each and it forms the bond F single bond F. Next one is the oxygen again. So here this is the formation of the carbon dioxide molecule. Okay. So now here oxygen is present in the group 16. So it is having a configuration 2, 6. So the 6 electrons present in the outermost shell over here. It needs 2 more electrons to complete the shell. Carbon atom is present in the group 14. Carbon is having the atomic number 6. So the 2 electrons present in the first shell, the 4 electrons present in the second shell. So the carbon is a tetravalent, we know that. So carbon can able to make the 4 bonds. So oxygen can able to make the 2 bonds. So these 2 electrons will be shared by the one oxygen atom and these 2 electrons will be shared by the one other oxygen atom. So carbon needs 2 oxygen atom to share the 4 electrons. So carbon here, the 2 electrons it's shared with one oxygen atom and it's sharing the other 2 electrons with the other oxygen atom. So it's making the double bond. So carbon is making the double bond with one oxygen and here the double bond with the other oxygen atom. So it's a linear molecule. Next one is the carbon tetrafluoride. So fluorine is having a atomic number 9. So the splitting of electron is 2, 7. So 7 electrons are there in the outermost shell. So fluorine wants to attain the stable outermost configuration. So it needs one more electron to complete 8 electron it needs, but here it's having a 7 electrons. So it's looking for the one more electron. Now the carbon is having a 4 electrons in the outermost shell. So carbon can able to share the 4 electrons at a time, but fluorine can able to uh, share the one electron. So each electron will be shared by the 4 fluorine atoms. So the carbon is sharing the one electron, one fluorine atom is sharing one electron. So carbon is sharing here. So like this, the carbon can able to make the 4 single bonds with the 4 fluorine atoms. So it's a CF4.